Here's a classic interview question that instantly reveals how deeply you understand classification models. Can you explain what a confusion matrix is and how to interpret it? Here's how to answer this, with both clarity and confidence. A confusion matrix is simply a table that shows how well your classification model performed by comparing actual versus predicted values. It breaks results into 4 parts. True positives TP, cases where the model predicted yes, and it was actually yes. For example, a fraud detection model correctly flagging a real fraud. False positives FP, the model predicted yes, but it was actually no. That's a type 1 error, flagging a normal transaction as fraud. False negatives FN, the model predicted no, but it was actually yes. That's a type 2 error, missing a real fraud case. And true negatives TN, cases where the model predicted no, and it truly wasn't fraud. The confusion matrix helps you see where your model is getting confused, whether it's making too many false alarms or missing true positives. So a great way to frame your answer in an interview is like this. A confusion matrix gives me a full diagnostic of my model's performance. It tells me not just how often I'm right, but how I'm wrong. That single line shows maturity, because it's not about accuracy alone, it's about understanding the cost of your model's mistakes. Once you've explained what a confusion matrix is, the interviewer might follow up with, okay, how do you actually use it to evaluate your model? Here's where you show real expertise. From the confusion matrix, we derive all key classification metrics, and each one tells a different story about model performance. Accuracy measures the overall correctness, how often the model gets both positives and negatives right. Precision tells you, of all the cases the model predicted as positive, how many were actually correct. It's great for situations where false alarms are costly, like flagging legitimate transactions as fraud. Recall, also known as sensitivity, asks the opposite question. Of all the true positive cases that exist, how many did my model actually catch? This becomes crucial in scenarios like medical testing or fraud detection, where missing even one positive case can be expensive or dangerous. Then we have specificity, which focuses on the negative side, how well the model correctly identifies the no cases. And finally, F1 score, which blends both precision and recall into a single balanced metric, perfect when your data is imbalanced, and you want a fair measure of both catching positives and avoiding false alarms. Now here's an interview gold tip. Don't stop at the formulas, connect the metrics to the business context. For example, in a fraud detection project, I'd prioritize recall over precision, because missing a fraudulent case costs more than investigating an extra false alarm. That one sentence transforms your answer from textbook to real-world problem solving. Remember, knowing how to calculate metrics is good, but knowing when and why to optimize them is what gets you hired.